This video will be an overview of many of the different types of angles we've looked at: central angles, inscribed angles, angles formed by a chord and a tangent, and so on. Most of these, the majority of these, are included in this diagram here. So we have given the angle and arc measures shown in the figure, and that BA and DC are tangents. Find all of the numbered measurements. It tells you that the center of the circle is at 4. So the numbers that we have here represent either arcs. The ones outside the circle basically represent arc measurements that we have to find, and the numbers inside the circle represent angles. And it tells you the center is at 4. So this point right here, where these two chords intersect, represents the circle, the center of the circle. So this angle right here, and again, try to do my best with these values here, but this is actually, 20 degrees actually is for this angle here. So we want to find the measurements for the numbered section. So 1 then would be this arc right here. And since this is a central angle and it measures 20 degrees, then arc 1 is 20 degrees. Now in the same way, because this angle there and this angle here are vertical angles, this one has a measure of 20 degrees also. So we don't have a number there, but that'll give us the value for this arc here, 6. Because the central angle has to have the same value or measurement as the arc. So this arc over here, if this is 20 degrees, this has to be 20 degrees. So that's 20 degrees here. Let's look at angle 3. And notice here the vertex is on the center. So this is an inscribed angle. So this angle here is going to be half the measurement of the intercepted arc. So that means arc 1. That's 20 degrees, so half of that is 10 degrees. So for this one, this is 10 degrees. That angle is 10 degrees. Notice now, angle 5 right here, that's also an inscribed angle. So it has to be half the measure of the intercepted arc. So that one intercepts this arc here, number 6, which is 10 degrees, or 20 degrees I should say. And the rule is to take half of that for the inscribed angle, so this has to be 10 degrees. So there's different ways you can go here. The order is not that important. You want to go in the sequence 1, 2, 3, 4, and so on if you can. So now this one here is a triangle now. We have 3. Angle 3 has a measure of 10. Angle 5 has a measure of 10. That's 20 degrees total. We know a triangle has a total of 180. So subtract 180. Or subtract 20 from 180. We get 160. Just going to put this over here. Angle 4 then. And then I'll give you a chart after this to make, just in case it's not that clear. But angle 4, because the total degree measure in a triangle is 180, 10 and 10, subtracted from 180 is 160. So this one has a measure of 160 as in degrees. And over here, for angle 7, that's this angle right here, just to make it clear. Angle 7 is right there. And the arc right here that's created by this chord and this tangent, DC is a tangent, is going to be half of the value of the intercepted arc. So it's this one right here. So this angle right here then is 50 degrees. Now this one over here for 10, notice they give you this angle right here. They tell you that's 45 degrees. So this angle But here, in this situation, when you have a tangent and a secant or a chord, it's always half the measure of the intercepted arc. So that means that this arc over here, going the other way, multiplied by 2, so this should be 90 degrees. This angle here is half the measurement of the arc. And going the other way, the measurement of the arc is twice whatever this angle is. So 2 times 45 is 90. So angle 10 has a measure of 90 degrees. Now let's look at 8, this arc right here. Now again, remember that the arc measurement all around the circle is 360. So you have half a circle, it's 180. So let's look at this one. This right here, I put the arrows. Notice that goes through the center. So that's a diameter. So the total degree measurement around this arc here, around the circle there, should be 180. So if we look at this diameter right here, so again, this diameter here, where I have the arrows here, look at the arc. Here we have 100. So all the way around, that has to be 180 to this side over here. And we got a measurement there of 100, and here's 20. That's 120. So for this section right here, numbered 8, that would have to be 120, and then 60 more would give us 180. So this would be 60. So what are we missing now? You got 1. Okay, 2. Now let's go to 2 here. This angle right here is an inscribed angle. Vertex is on the circumference of the circle. It intercepts an arc of 20 degrees. That's this one here. So the rule is to take half of that. So angle 2 would be 10 degrees. Now let's look at angle 13 here. This angle right here. It's inscribed. Vertex is on the circumference, and it intercepts an arc of, right here, 90 degrees. So by rule then, the value of that would be half of 90. So this angle right here would have to be 45 degrees. Now let's go to angle 9 here. This angle right here, that's an inscribed angle. Vertex is on the circumference. The arc over here, which is 8, is 60 degrees. So the rule is you have an inscribed angle, take half the value of the intercepted arc. So half of 60 is 30. So this will be 30 degrees. Now for number 11, we've got pretty much all the arcs filled in. We got 20, 60, 50 is the angle here. So the arc is 100. So we got 20, 60, 100, 20, and then 90. So we add those up at 200 and then 290. So there's 70 degrees left. So 11 would be 70 degrees. This arc, number 11, is 70 degrees. And now this angle here, which is number 12, it intercepts this arc, which measures 70 degrees. So by rule, we take half of that. So angle 12 would be 35 degrees. So now all we need, I believe, is angle 14. And that's one of the angles from this triangle here. We have one to be 35, one to be 45. Get those up, that's 80. We know the total has to be 180, so subtract that from 180. And angle 14 is 100 degrees. So it's a little bit messy. And sometimes it's difficult to follow something like this. But it does include all the different, pretty much all the ones, different types of angles that you can have in a circle. Most of them anyway. And just so you can see it clearly, you want to go back and do it on your own. Here's the solutions. So angle 1. Well, most of these are arcs. So depending on where it's at. So let me just say, the measure for number 1 is 20 degrees. The number 2 is 10 degrees. Number 3, 10 degrees. Number 4, 160 degrees. Number 5, 10 degrees. Number 6, 20 degrees. 7, 50 degrees. 8, 60 degrees, 9, 30 degrees, 10, 90 degrees, 11, 70 degrees, 12, 35 degrees, 13, 45 degrees, and the last one, number 14, was 100 degrees. So again, you can take these down if you want and see if you can redo the problem on your own. Thanks for watching. We'll see you next time.